Okay, we've got a little job here. So I've been asked to reproduce this part, which has a spiral groove in, except it needs to be the opposite helix. So this is off a motorbike throttle. So the hand grip would be around here somewhere. Well, I think the problem is that when the hand grip is rotated, this pulls or pushes on a wire which operates the throttle on the carburetor. So the guys changed the carburetor to a different type, so it needs to go from a pull to a push, or a push to a pull, not quite sure which, hence the need for the opposite helix on the shaft. This is also case hardened, so that's something else we'll have to do, but it's quite an interesting little job. So I've turned up a blank. So we'll get to the milling machine and have a look at the setup. Okay, this is my coupled together spiral milling attachment. So this is a headstock off an old Drumond lathe, and I've fitted with a collet chuck. Okay, so the headstock is driven from the lead screw. So to get the correct spiral on the shaft, I determined that if I use a 40 tooth pulley here and a 36 tooth pulley here, it'll give me the right helix on the spiral. So I already had the 40 tooth one available, but I had to make the 36 tooth pulley for the lead screw. And also to get the opposite rotation of the helix on the part, I had to reverse the direction of the spindle. Initially I was thinking of putting a couple of gears on here somehow to get the reverse direction, but then I decided I would just try twisting the belt. I wasn't sure it would work that well with a timing belt, but it seems to be okay. So the idea is when you turn the lead screw, it rotates the chuck so you can mill a spiral. There's a bit of backlash in the system, so we have to be careful about that. So the chuck is held onto the headstock with a right hand thread, and we're cutting a left hand spiral, so we might need to be careful. Hopefully we won't unscrew the chuck. We'll touch on, just take a light cut, see what happens. It's looking promising. Take another cut. I'm happy with that so far. The cutter I'm using here is 7mm, so I've just gone along and made the groove wider on each side until this 8mm end mill fits in there. So we'll just try the mating part. Yeah, it fits. That fits really nice actually. Chuffed with that. Phew, that's a relief. Okay, that's done. Just needs case hardening. Looks pretty good though. Fits in there just nice. There doesn't seem to be any play on the pin that's on the inside. Pretty smooth. Should be good. So that's it after case hardening. It's cleaned up quite nicely. And the small file's not even marking it. So it looks good.